Geometry kids, we're back to example 3, section 3.3, and now we're going to do a proof. Most geometry students, including me when I was in geometry, did not really appreciate proofs when I was learning them, but this is a systematic, step-by-step way of using your logic to prove that you're correct. And so we're going to kind of delve into this. I'll go slowly, make sure you're hanging in there. I just honestly believe if your logic is good and you can track it step by step by step, then I don't think your proof will be wrong. Okay? Now, if there's something missing in your proof, that's really the only thing that could possibly make it wrong. But if you are being very logical and in your stepwise progression, creating a pathway using your statements and your reasons, that's why we're keeping an electronic notebook, is because those reasons are postulates and properties and theorems, maybe even definitions, who knows, okay? And so that's why you got to keep up with that so you can refer back to it very easily. All right, so let's go ahead and get started. I usually start making a chart. So we'll make a statement column and then a reasons column, and we'll number each of them, okay? I always put first the given information. I get that out of the way. Your book does it a little bit differently. I don't know if you brought your book home or not, but they broke it up. This is given information, so that always goes on your proof chart as your statement, and then your reason is given, okay? They broke it up, so I'm going to try and emulate the book just a little bit, and I'm going to try to stick close to it, but there is wiggle room. I would go ahead and make the given statement L is parallel to M, and angle 1 is congruent to angle 3. I'd do that all on one line. I wouldn't necessarily split that up necessarily, but you know, to each his own. All right, let's take a look. A lot of students are just like, I don't know where to start. I don't even know how to map out how to get from point A to point B. I don't know what to do. That's a lot of times what I hear from students. And so what I would do is, before you even start writing anything down, let's map out a very, very basic plan and see what details fall into place, okay? The first thing I want you to focus in on is the fact that they told us that line L is parallel to M. Line L is parallel to M. And we know that because they gave that to us. We need some given information, and that's what they gave us, and they marked it on our diagram for us, okay? So because we're focusing in on these two lines, and we're focusing in also on angles 1 and 3, we're not quite ready for angles 1 and 3 just yet. I think there's a couple of things to consider. All right, angles L and M are parallel, and I want you to focus on this transversal. First of all, just ignore this in your mind's eye. Just ignore that bottom transversal marked, whatever was marked for, I wrote over it, and R, I guess, line R. Just ignore that and just focus on lines L and M being cut across by the transversal P. We know that L and M are parallel. So what can you say about angles 1 and 2? Just what do you know has to be true about angles 1 and 2? And if you're going, oh, I see what to write here. Angle 1 is congruent to angle 2. Why can we say that positionally? Look at where they're located. And you go, oh, I see. They're corresponding angles. And so we learned the corresponding angles postulate, and that tells us that if you have two lines that are parallel, then the corresponding angles are congruent. And so that's why we can say that, okay? So we can say that they are congruent for that reason. Excellent job. Okay, So now that we've determined that, let me get my eraser out and let's take some of this off of here, okay? Now, let's get to step 3. Let's bring in that other piece of given information, and let's talk about angle 1 being congruent to angle 3. We know this because that is given. That was given information. We don't have to figure that out. That's given. Okay? And then let's label step 4. So if angle 1 is congruent to angle 2, and angle 1 is also congruent to angle 3, then what's true about these 2 angles right here? They have to also be congruent. They have to be. Because now what we want to do is we want to focus on these 2 lines, line P and line R, being cut across by the transversal M. Because our goal, look at where we're trying to go. We are trying to figure out if P and R are actually, if they're actually parallel. We know that L and M are because they gave it to us. They said, yeah, those are definitely parallel. But we don't know that P and R are parallel. We have to prove that. That's going to be our very, very last step. Whatever is what you're trying to prove, that's where you end up. Okay? So I always say step 1's your given, and your last step, however many steps in between, your last step's always the prove, and with your final assessment, your final reason. Okay, so we can say that angles 2 and 3 are congruent because of, think back to kind of an algebra property that we learned, and that would be the transitive property of congruence. Okay, and so transitive property, we said, well, if A equals B and B equals C, then A has to equal C. That's what we learned in algebra, and so it applies in geometry too with angles. If angle 1 is congruent to 2 and angle 1 is also congruent to 3, then 2 and 3 have to be congruent because they are congruent to the same angle. So now, do we have enough information? Look at, if we're saying that angles 2 and 3 are congruent, look at them positionally. We're saying they're congruent. So how can we say then that R is parallel to P, knowing that angles 2 and 3 are congruent? What could you put there as your reason? Okay, think back to something we just used. And if you're thinking, oh yeah, Mrs. Thompson, that would be the converse, because we don't know that the lines are parallel, so we're using the converse of, and what are the angles positionally? What are they known as? The alternate exterior angles theorem. Good job. All right, now I'm sorry I took so long to kind of get you through that and guide you through that, but I wanted to go slow, give you a chance to process. And proofs aren't easy, so I don't think doing them fast will serve you. So anyway, we will practice more of these in class, but you've just gotten a good dose, heard it, and you can go back and rewind and listen to it again at a later time, maybe right before our test, and practice that again. You don't get better at something unless you practice. Avoiding proofs doesn't make, you don't get better at them if you avoid them. So as much as I don't like them, I get better when I practice. So I'm going to give you the same advice and the same courtesy. So please don't shy away from them. Stick with it. Use your logic. And I think you can figure it out. Okay? Bring your questions to class and we'll see you tomorrow.